Okay, so this is like another example, right? Another example is, let's say example, I mean, this is example number 2. Let's just, I want to give you another example. Example, right? And let's say what is given is 172.1.4.0, right? And then this is slash 25, right? And then what? Let's say 172.1.7.0 slash 25. No, I think this should be 24. I think there's a, okay, so this is 24. Oops. And then 172.1 dot what? 6.0 slash 24. And then 172.1 dot, let's say 5, right? Slash 24. And then 172.1 dot 4 dot 128 slash 25. Okay, so this is given, right? And then I want to find the summary route, right? And then summarize this IP address, and then what? Then subnet mask, right? So what is it? Okay, so step number 1, and I said the convert the address to binary, but let me just add one more. Maybe step number 0 is when you list this IP address. So I'll just say step number 0 is when you list the IP address, list all the IP addresses from smallest to the largest. Okay, so okay, LAR. Largest. Okay, and actually the reason that I say step number 0 is this is not really necessary. It's not like, but it's better, right? It's better. In that way you can make a less mistake. Okay, so if you look at this IP addresses, right? And then also maybe I should add one more, and then like to do this you have to find interesting octets, okay? That way you don't have to convert all the portion of the IP address to the binary. You only convert the interesting portion of your IP address to the binary. Okay. So now first let's take a look at this IP addresses, right? And we know that 72.1, right? We know that 72.1 is really same. 72.1 and 72.1 and 72.1, right? So this is not really interesting. They're all common. However, if you look at the third octet, 47654, right? So these are the interesting octets, right? So that's the ones that we have to reconvert the decimal to binary, right? And then another thing, okay. So which one is really like smallest? You see that is 4.0 is probably smallest, right? So this is the smallest, right? Because it's 4, and the next one, and then it's 4, right? So this is the smallest, and then the second smallest is this guy, because of 4.128, and third is this 5, 6, and 7, right? So let me just list this IP address from the smallest to largest. So smallest is 172 dot, right? 1 dot, and then 4 dot, right? And 0, right? The next one is 172 dot 1 dot 4 dot, and then what, 128, right? So I think this is also a change. I guess we have to also change this binary, but we'll see. Okay, and then the next one is 172 dot 1 dot 5 dot 0, right? And then 172 dot 1 dot then what, next one is a 6, right? Okay, the 6 dot 6 dot what, 6.0, and then the 7.0, right? And the next one is 7.0. Okay, so that's the IP address, right? So the 4.0, I'm gonna convert this into convert this into the what? To the binary, right? 4.0, right? So the 4.0, right? So the 4 is what? Okay, so 100, 100. Okay, so let's see. So 4 is 0. Oops. The 4 is what? 0. Oops. Let's draw this guy. Okay, the 0, 0, 0, 0, right? And then 0, 1, 0, 0, right? 1, 2, 3, 4, 1, 2, okay. 1, 2, 4, okay, 1, 0, 0, right? That's a 4, and then 0, right? And then it's going to be 0, 0, 0, 0, 0, 0, 0. Okay, now the 4 is the same thing, right? I'm going to convert this 4, right? And then I convert this 128, okay? Actually, you don't have to convert 128, but I'll do it anyway. 4, it's 4.128, right? So it's 0, 0, 0, 0, 0, 1, 0, 0, dot, right? And then 128 is 1, 0, 0, 0, 0, 0, 0, 0, right? 1, 2, 3, 4, 5, 6, 7, 8. Good. Okay. And then now I'm going to convert this 5 into binary. And then 0 is just 0, right? So let's say 5.0, it's what? 0, 0, 0, 0, 0, 1, 0, 1. That's a 5 dot, and everything's a 0, right? Okay. And the last one is a 6, right? 6.0. So for 6 is what? 0, 0, 0, 0, 0, 1, 1, 0, right? So that's a 6 dot and 0, right? So it's all the way to 0. Okay. And then last one, 170 to 1.7.0, the 7, I have to convert 7 to the binary, right? The third octet, right? So the 7 is what? 172 dot 1 dot 7 is what? 0, 0, 0, 0, 0, 1, 1, 1 dot, right? And 0 and all the way to 0. Okay. So now that's your first step, right? 0 and first step. And step number 1 is step number 2 is to find all the common bits, right? From the left to right. So you have to identify the common bits and the variable bits, right? So now it's time for you to draw the line. So let's just try to from the left to the right. So 172.1 is obviously common, right? There's no change. And then now let's look at these interesting bits. 0 is a common, yes, everything is a 0 here. And then everything is a 0. And then 0, 0, yes, there's all common. And then what about the 1? Yes, it's 1, 1, 1, 1. Yes, they are all commons, right? But however, when I go to this this bit, if you look at this column, 0, and they are not really common because this is a 0 and then this is 1, right? So this is not common bits. So I'm going to now using the red to identify the commons. So right there. Right? So that's my common bits. Okay. So I can summarize this IP addresses. First, I'm going to just summarize the IP address. So 172.1. And then for the common bits, I'm going to just copy them down exactly. So it's going to 0, 0, 0, 0, 0, 1, right? And then remaining bits, I'm going to put all 0, right? Just like a subnet mask. And it's going to be 0, 0, dot. Everything is going to be just 0. Okay? Okay, so that's my summary route, summary IP address, right? Okay? And then for the subnet mask, same thing. Build a subnet mask, Build a subnet mask that puts 1 under all of the common bits in the range, right? And then remaining bits, you put 0, right? So it's going to 172, it's 8 bits, right? So it's going to be 1, 1, 1, 1, 1, 1, 1, 1, 8 of them, dot. And then this is the second octet, so it's going to be 1 1 1 1 1 1 1 1 dot, right? And then 1 1 1 1 1 1, then what? 0 0 dot, and then remaining is all, you put all 0, right? So under the what? Under the all variable bits, basically for both IP address and then for the subnet mask, you put 0, right? You put the 0 under the variable bits, right? So it's going to be all 0. So this is your common bits, right? This is for the common bits. Okay. And then you're going to put all 0, right? So I'm going to put 0 and then all the way to 0. Okay. So that's the answer. So what is my summary route? My summary route is 172.1.000000100 is a 4, right? 4 dot, right? And 0. And then what? The subnet mask, right? The subnet mask is, okay, subnet mask is what? This is 8, so 16, right? 8, 8, 16, and 17, 18, 19, 20, 21, 22, same, right? Okay, same. So it's a 22, right? And then, right. And then, so 22 means what? Okay, so 22 means basically 255, 255, 255 dot, 255 dot, 240, no, actually not 240, 252, right? Okay, so 252.0, right? Okay, for the summary node you usually use prefix notations. Okay. Okay, so that's the answer. But okay, now the thing is, okay, so this is a really good example because I like to show you. This is like this is the way you should use to identify or define the summary route and the subnet mask, right? But you can also solve this using your intuition. Okay, that's the reason that I show you this example. Okay, so let me just explain what I mean. Okay, so basically what I mean by that is I want to understand the subnetting, right? We learned subnetting and route summarization, right? So, for the subnetting, right? So let's just review what the subnetting with the VLSM, right? Subnetting, right? The subnetting is it's a process of lengthening the mask, right? So let's just write. So basically, subnetting is what? The subnetting is a process of lengthening, right? Lengthening the mask, right? To create a multiple smaller network, right? To create multiple smaller network, or you can call it multiple smaller subnets, right? From a single large network. Okay, but the route summarization, right, is exactly opposite. For the route summarization, by the way, this is not in your textbook, right? This is not in your textbook. However, I want you to know this. I mean, this is very helpful. Help you to understand this subnetting better, or the routing summarization, right? And for the routing summarization, you can describe as what? This is a lengthening, right? Lengthening the mask. But routing summarization, as you can see, we have a 25, 24, 24, right? And then your final answer is 22, right? So it's not lengthening, it's shortening, right? It's shortening the mask, right? Shortening the mask to include several smaller network, right? To include several what? Smaller network, right? Into one large network, right? Okay, so you have a smaller network, right? You have a smaller network now. You want to include this all smaller network into what? One large network, right? So it's really opposite. If you think about it, the subnetting or the VLSM it's what? It's a lengthening, right? The mask, and this one is what? It's opposite, shortening. And then to create multiple smaller network, right, from the large, right, from the single large network, right? But this one is what? It's combining all the smaller network into one large. So exactly the opposite. For the conceptually, you will see that subnetting and routing, route summarization is exactly conceptualized. If you look at in the concept, the exactly is the opposite, right? That's something I want you to know. Now, let's just use this as an example, okay? So let me just write down this IP address, right? From smaller to the largest. I showed I'd like to show this idea, okay? So now my IP address is what? 172.1.4.0 and then /25. And the next one is this one, right? So 172.1.4.128/25. And next one is 172.1.5.0/24, right? Okay, and then 172.1.6.0/24, and the next one is 172.1.5. Okay, 7 is the last one. Okay, the 7.0/24, right? Okay, and then you know that this is our answer, right? For the summary route, that's the my summary IP, right? Summarize the IP address. Okay, so I'm gonna include all this smaller network, right? Smaller network to the large network, right? Okay. And now, so the thing is, okay. So I want you to look at the Class B of VLSM chart that you learned, right, in my previous lecture, right? So this is a Class B large address. Okay. In the VLSM, right? VLSM, what I did was, okay, here's the 172.1.4.0/22, right? And then I'm gonna give you some requirements, let's say, such as like number of host IP addresses and etc. Right? I give you some requirements. So from this, basically, what you should create this subnets, right? So that's like subnetting or the VLSM, right? This is a subnetting and like a VLSM, okay? But the opposite process is a route summarizations, right? The route summarization is what is given is this smaller subnets, right? And then you need to come up with a large network. So you see the process is exactly opposite, right? Now, actually to find the answer, you can use a Class B. You can use the this VLSM chart. Okay. So now another thing that you should know is that this is a /25, right? This is /25, and then this is /24, right? So I know that those who I know that there's a couple of you already noticed, right? The /25. So this one is what? The /24 network is even like subnetted further to have 2/25 network, right? So that means originally you have so basically you have 172.1.4.0/24, right? And then you have 172.1.4.0, 5. Okay, so insert, draw, okay. So the 5.0/24 and then 172.1.6.0/24, right? 172.1.7.0/24. Okay, so the /22 network, right, is now subnetted into this 4 different network. Okay, then this this chunk, right, this /24 network is like further subnetted into this 2 network. Okay, so that's why it's a /25. Okay, so if you just draw the diagram, you should able to draw this network diagram, Okay, so let's say there's a router, right? Router has another network, right? This network is, I'm going to use this, right, which is 172. So this is another like cloud small network, 172.1.7.0/24, and then there's another network, right? And this one is this guy, and then there's another network, right? And this is this one, 172.1.0/24, and now we have 172.1.4.0, right? But we subnetted into these 2 different smaller network with equal size so this network .4 will be divided into half, right? And then first half is this guy, and then second half is this one, right? So that means, okay, so this is like an in-depth treatment of okay, so that means you have another router, right? You have another router, and then you have another small network, and then like another small network, right? And this time this one is what? 172.1.4.0/25, right? And this one, another second half is 172.1.4.0. Actually no, it's 128. Sorry. 128/25. Okay, so that's what's really then, right? Maybe my diagram is not really pretty, so I want to make this pretty. Okay, so what happened is you have a router, right? This big router, and then small router, and like this, right? Okay, now then let's say it goes to internet, for example. Internet. So for this guy, right? It has to sense by the way, this is local net. This is like a router located in the local area, right? Okay, so for the summary route, for this router can sense this one. Sense this guy, the summary route. So at the end, to advertise, it's entire, right? To advertise this entire network, right? And then he can summarize as just one route, one IP address, and he can send it to the internet. It's advertising, hey, my summary route is what? 172.1.4.0/22, right? Because this number, this IP address, is really summarize this entire network. Okay, but anyway, that's okay. So now let's just talk about the how to find the summary route, from this list of the small network. Okay, and by the way, okay. So let's just look at the Class B VLSM chart. Okay, so if you look at this VLSM, Class B VLSM chart, okay, first of all, right, I know that this two of them can be summarized as this /24, right, basically, right? Okay, now, if you look at this, what is really interesting, octet is 4, 5, 6, and 7, right? So I know that my common bit is at least greater than 16, right? Less than 24, right? So because I know that this is a 16, right? 255.255, and then it's going to be something, right? And but it's going to be less than 24, right? So I know that my subnet mask is greater than 16, so it's going to be 17, 18, 19, 20, 21, 22, or 23, right? But let's just, right? First of all, that's something you can guess. And then I want you to take a look at this /22, right? You will see the interesting number here. 427. You see that 427? So that means 4, 5, 6, 7, right? 4, 5, 6, and 7, right? So you know that what? You have to use /22, right? Okay, I mean, you can use both way. I mean, I recommend this first, this method 1. And this is, I want you to, okay, you don't have to use this, right? But the reason that I show you this anyway is I want you to have an intuition, okay? Instead of, oh, I'm just following this method blindly. I don't know much about, this. I don't want to think about the network structures and etc. But that's not a really good way, right? And I want you to have an intuition, and that's why I'm showing this. Although this is not really necessary to solve a homework or the exam problem, right? Okay. And another thing is, like, there's like a third way, right? The third way is, again, you don't have to use this. You know that interesting octet is 4, 5, 6, 7, right? Okay. So this block, right? So this block, basically, that means this block, right? 4 to 7. It's so it's going to be like, if this is going to be one block, right? One summary, then you know that your address is going to be like 0, 4, then 8, right? And then 12, right? Etc. Okay. So remember, in the VLSM or the subnetting topic, right? We know that the formula that we use is 256 minus something, right? So this something is really give you the block size, right? So let's say, so if this is going to be one block, that means block size should be the 4. So it should be 0, right? It should be 0 and then 4, and the next is 8, and then 12, and 16, and 20, and 24, etc., right? So you know the block size has to be 4. That means something, and then block size has to be 4, right? So because of 0, 4, 8, 12, and if you know that this is right now, its block size is 4, right? Because 1, 2, 3, and 4. Okay. So that means this has to be what? This has to be 252, right? Which is /22. And that's another, and then, so to find the summary node, you can only look at the first IP address in the block, and this is going to be a subnet mask. So answer is 172.1.4.0/22. Okay, so that's the answer. And so if you use the intuition, you don't have to go through this process, right? This is kind of a lengthy process and it takes your time. However, I think especially for your homework assignment, I use this method. And then after you use this method, and think about this method, second and third method, right? To verify your answer. And also, I think it will help you to have a intuition, okay? And so That's why I show this method 2 and you know, actually second and third methods are exactly the same thing, right? So you can think this is like a method 1 and this is like a method 2, right? But this is like used only to verify the answer from method 1, okay? But I hope this will help you to have a intuition, okay? So I'm done.